excuse me, 9.4 deals with the timber post. I'm not big on doing wood stuff since we're mechanicals, but what the heck. It does illustrate compression. That's the only reason I want to look at this one. It says compute the required size of the short, square, dressed S4S timber post shown in figure 9.5. That's this one. The post is subjected to a compressive load of 100 kilonewtons. The allowable axial compressive stress is 5.5 megapascals. So again, that is given to you in this example. Otherwise, you might have to go out and look for that. Okay. So this is a design type problem. Since the size of the member is to be found, so that's where we have to just rearrange that equation in the table that we had earlier. Required cross-sectional area is found using equation 9.2. So the load is shown in newtons. So they've got the area equals what? The force, which was given as, it was given as what? 100 kilonewtons. So 100 times 10 to the third newtons. Right? That takes the place of kilo, doesn't it? 10 to the third. That takes care of your kilo. Okay. And then divided by the let's see, by the allowable stress, which was given as, it was given as 5.5, wasn't it? Yeah. 5.5 megapascals. And that's what we had to convert into back in that previous problem. So we don't have to convert that out. We did have to convert the 100 kilonewtons into newtons. And then megapascals is meters. What was that? The meters squared? Square meters. Okay. And let's see, we're looking at, when you punch that in, you're looking at 18.18, was it? 18.18 times 10 to the third millimeters squared. That's interesting. Megapascals, now that was, they did a real big leap there, didn't they? Yeah, they did a real big, they went from, this should be, this was, if this was 5.5, yeah, this would have been meters. Well, no, that's not meters squared, so that would have to be millimeters, I guess, because we're looking for the area. But that should have come out as meters, shouldn't it?
You converted.
Yeah. Well, this this 5.5, let's break that down, megapascals is equal to what? Let's see, it'll be 5.5 times 10 to the 6th Newton meters squared. Right? Yeah. And then all of a sudden, in some real quick leap, we went to millimeters squared. I don't think so.
Well, if you wrote it as 100 times 10 to the third newtons over 5.5 times 10 to the 6th Newton meters squared, don't only your newtons cancel out?
10 to the third
Yeah, just like you have it on
newtons.
top. And then 5.5 times 10 to the 6th.
Right.
That's basically what they're writing, right?
Newtons per meter squared. Right, but what I'm saying is all of a sudden they went to square millimeters.
Yeah,
It's
but then your
square
newtons-
meters right
then your
here.
Newtons cancel, and your 10 to the third over your 10 to the sixth just
Goes to 10 to the third.
which is where you get your millimeters.
Right. This, but you're left with, what does that come out to? Does that come out to
Doesn't that
something
just-
10 to the third?
Yeah, shouldn't that just reduce down to your 10?
Well,
to the
that's
third
what
and
I'm
that-
hoping, but
Yeah.
punch that in real quick and see what you get.
The numbers come out, right? But I'm
What, well, wait a minute, what does the number come out to?
18.18 times 10 to the third, or
Okay,
18,181.
right, times 10 to the third,
Yeah,
which means that it is in millimeters at that point.
at that point.
Yeah.
So the relationship between a
It's -3, I think.
Do what?
yeah, it's -3.
It's -3, not.
Oh, oh.
And
Well, then that would be 10, that would be -3 would be meters still then, right?
Yeah,
Yeah.
so then to make it positive, they put.
So I am going to have to get my eraser out here. Let's see. So that's meters squared. So then they, to make that right,
Yeah.
times 10 to the third millimeters. Yeah. To go from meters to millimeters, you'd have to go that.
and since it's square, you have to multiply by 10 to the power 6.
Right. Which gets you back up to 3. Yeah. Okay. So it's like, oh, wait a minute. Big change. Okay. But I think the main thing there was you needed to know what that area was going to be. So you plug the numbers in there that you had, that were given to you. Note from Appendix E, Table Table E2, a nominal 150 millimeters by 150 millimeters square timber member has a cross-sectional area of 19.6 times 10 to the third millimeters based on addressed dimensions of 140 by 140. Therefore, select the 150 by 150 timber. Let's see. Yeah, so if you go back and look, Table E, so what they're telling you there is, excuse me, I'm getting kind of worried about that cough. Let's see. Table E2, which is actually on page 496 in your book. So the nominal size of 150 by 150 has a cross-sectional area of 19.6. Dress size, and actually that's on page 497. Try to mark my pages here. Let's see if we go and look. So we knew that the area that we wanted was 18.18 times 10 to the third square millimeters, right? Note that the size, square millimeters times 10 to the third, right there, right? In your chart. Okay, so we're looking for something in this chart that's going to get close to that 18.18. And that's this column right here, right? So 18.18 So let's see, is there anything else that would, there's an 18.2, an 80 by 300 would work, wouldn't it?
Yeah.
Okay, 18.2, but that's pretty close. That's pushing the limit. And what they're saying is, use this 140 by 140. Now, was there any stipulation that said it needed to be square? Because that would be something, you know, if you were going for a square. It did say square? Well, there you go. We could have possibly used the 80 by 300, but since it says to make it square, that throws that out the window, doesn't it? So then we would have to go with this 150 by 150 because it's got the 19.6, which is more than the 18.8. So you wouldn't want to go anything below that because then you're getting out of your range. Okay, so once you find out the area, whether it's square millimeters or square inches, you have to go back to your chart and make sure what you think is going to work will work. Okay, and so you're not done with the problem when you figure out, okay, well, there's my square whatever, millimeters or inches.
And that's the number that the manufacturer, whether it's steel or wood, has put that under to get that.
Well, in this case, no. In this case, you found out based on that has nothing to do with. You'd have to go back and look at your other properties, make sure that it would withstand that stress. But just because the area matches up doesn't mean that the material is going to hold up to that, does it? So, but in this case, yeah, we could go in and say, okay, well, we have to have a 18.18, so we'd have to go with a 150 by 150. All other things being equal and legitimate, okay? Because if that was a piece of plastic, you know, it might 150 by 150, but then you would be looking at, well, that 5.5 megapascals that we were talking about. Did it say in there? I think that. Let's see. Actually, no, it didn't say that, did it? Well, yeah, it tells you the stress, but it doesn't. No.
Wow.
Yeah, so we have to be careful there. Can't just go in and figure out one thing and say, well, that's going to work. Okay.
What's the difference between the nominal size and the dress size in the timbers?
The size. Oh, sorry, I couldn't pass that over. I think, and again, you got me at a little bit of a loss because it's wood, but if you think in terms of a 2x4 that you buy at the store, a 2x4 at the store is, 1.5 by 3.5, I think.
Yeah.
So,
The dress size would be the size the reality size of it.
Yeah.
Yeah.
The nominal size is what they call it.
Like they call it 2x4.
Yeah.
Yeah.
2x4 inches.
Yeah. But your dress size is really how it comes out to you after the mill.
I'm going with that.
Well, that was my
I think
guess.
that's
I think that's right. I don't know.
I've
like
seen it
to-
on blueprints before written that way.
Oh yeah,
Yeah.
as nominal or dressed.
It'll depict whether it's one or the other. Like
Okay.
Maybe on one page for some reason they describe the nominal size for like the siding guys because they need to know how long a nail is by or something like that. So it'll tell you which one from page to page.
Well, or even more so, the siding guys might want the dress size,
Dress size,
and
yeah, vice
the
versa.
purchasing guys might want the nominal
Yeah.
size. You know, it's a 2x4. To a purchasing guy, it's a 2x4. To somebody that's actually using it,
Yeah.
it's a dress size. You know, as far as that goes. Okay, what else here?